Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we will solve problems involving combinations. Let us have first a review on combination. A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. The total number of combinations of n objects taken r at a time is given by the formula n factorial all over quantity n minus r factorial times r factorial. Let us evaluate combination of 10 taken 2 at a time. Using the formula for combination where n is equal to 10 and r is equal to 2, we will have 10 factorial all over quantity and 10 minus 2 factorial times 2 factorial. Simplifying the operation inside the parentheses, we will then have 10 factorial all over 8 factorial times 2 factorial. Expanding the numerator, that is equal to 10 times 9 times 8 factorial all over 8 factorial times 2 factorial. Cancelling the common factor, which is 8 factorial, we will have 10 times 9 equals 90 all over 2 factorial, which is equal to 2. 90 divided by 2 is equal to 45. Let's now discuss problems involving combinations. How many different teams of 9 can be chosen from a group of 15 individuals? This problem can be represented by combination of 15 taken 9 at a time, since we are to choose 9 individuals from a group of 15. So using the formula, we will have n is equal to 15 and r is equal to 9. Substituting the values of n and r to the formula, we will have 15 factorial all over quantity 15 minus 9 factorial times 9 factorial. Or simply, 15 factorial all over 6 factorial times 9 factorial. Expanding our numerator, we will have 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial all over 9 factorial times 6 factorial. Since we have a common factor which is 9 factorial, we can now cancel this one out. Simplifying the numerator, 15 times 14 times 13 times 12 times 11 times 10 is equal to 3,603,600 all over 6 factorial, which is equal to 720. 3,603,600 divided by 720 is equal to 5,005. Therefore, we can have 5,005 different teams of 9 people from a group of 15 individuals. A club consists of 20 members. How many different committees of 5 be chosen from the club? The problem can be represented by a combination of 20 taken 5 at a time, wherein n is equal to 20 and r is equal to 5. Substituting the values of n and r in the formula, we will have 20 factorial all over 20 minus 5 factorial times 5 factorial. Or simply, 20 factorial all over 15 factorial times 5 factorial. Expanding the numerator, that is equal to 20 times 19 times 18 times 17 times 16 times 15 factorial all over 15 factorial times 5 factorial. Cancelling the common factor, which is 15 factorial, and simplifying the operations on our numerator, that is equal to 1,860,480 divided by 5 factorial, which is equal to 120. Simplifying the fraction, we will arrive at 15,504. A math exam contains 7 questions. Students have to answer numbers 1 and 2 and any 3 of the remaining 5 questions. How many different selections are possible? We have 2 operations here. We will have combination of 2 taken 2 at a time, simply because each student is required to answer the first two questions. And we are going to multiply this to combination of 5 taken 3 at a time because the student is allowed to answer any 3 of the remaining 5 questions. So that will be equal to 2C2 is equal to 2 factorial all over 2 minus 2 factorial times 2 factorial, which is equal to 2 factorial all over 0 factorial all over 2 factorial, which is equal to 1. Let us now simplify combination of 5 taken 3 at a time. Using the formula, we will have 5 factorial all over quantity 5 minus 3 factorial times 3 factorial, or simply 5 factorial all over 2 factorial times 3 factorial. Simplifying the numerator, we will have 5 times 4 times 3 factorial all over 3 factorial times 2 factorial. We may cancel the common factor, which is 3 factorial. 5 times 4 is equal to 20 all over 2. That is equal to 10. 1 times 10 is equal to 10. Therefore, we have 10 different selections possible. The committee of math club consists of 3 students chosen from 6 boys and 3 girls. How many committees can be formed if there are 2 boys and 1 girl? So since there is a restriction on this problem, the committee must consist of 2 boys and 1 girl. We will then have 6C2 since we have 6 boys and 2 boys will be chosen times 8C1 since 1 girl is to be chosen from the group of 8 girls. Let us first simplify 6C2. That is equal to 6 factorial all over 6 minus 2 factorial all over 2 factorial, which is equal to 6 factorial over 4 factorial times 2 factorial. Expanding the numerator, that is 6 times 5 times 4 factorial all over 4 factorial, and cancelling the common factor, which is 4 factorial, we will arrive at 6 times 5 equals 30 all over 2, which is equal to 15. Let us now evaluate 8C1. That is 8 factorial all over 8 minus 7 factorial times 1 factorial. 8 factorial all over 7 factorial times 1 factorial, which is equal to 8 times 7 factorial over 7 factorial times 1 factorial. Cancelling 7 factorial, we will have 8 over 1 or simply 8. To compute for the total number of committees can be formed, multiply 15 by 8 and that is equal to 120. The committee of math club consists of 3 students chosen from 6 boys and 8 girls. How many committees can be formed if there are 2 girls and 1 boy? So in this situation, there should be 2 girls and 1 boy composing the committee. So we will then have 8C2 since we have to choose 2 girls from the group of 8 girls times 6C1 since we should have 1 boy from the group of 6 boys. Let us now simplify first 8C2. That is equal to 8 factorial all over 8 minus 2 factorial times 2 factorial. 8 minus 2 is equal to 6 factorial. Expanding our numerator, we will have 8 times 7 times 6 factorial all over 6 factorial times 2 factorial. Cancelling the common factor, which is 6 factorial, that is equivalent to 56 over 2, or simply 28. Evaluating 6C1, that is equal to 6 factorial all over 6 minus 1 factorial times 1 factorial. 6 minus 1 factorial is equal to 5 factorial. Expanding the numerator, that is equal to 6 times 5 factorial all over 5 factorial times 1 factorial. Cancelling the common factor, which is 5 factorial, that is equal to 6 all over 1, or simply 6. Multiplying 28 by 6 to get the total number of committees possible, that is equal to 28 times 6 equals 168. What if the committee should have 3 girls? So in order for us to compute for the total number of committees can be formed, if there would be 3 girls in the committee, that will be 8C3, since we have 3 girls from the group of 8, times 6C0, since there should be no boy from the committee formed. 8C3 is equal to 8 factorial all over 8 minus 3 factorial times 3 factorial. Simplifying the parentheses in our denominator, we will arrive at 8 factorial all over 5 factorial times 3 factorial. Expanding the numerator, that is 8 times 7 times 6 times 5 factorial all over 5 factorial times 3 factorial. Cancelling the common factor, which is 5 factorial, that is equal to 336 all over 6, or simply 56. Let us now have 6C0, or a combination of 6 taken 0 at a time. That is equal to 6 factorial all over 6 minus 0 factorial times 0 factorial. 6 factorial all over 6 factorial times 0 factorial is simply equals to 1. Multiplying 56 by 1, that is equal to 56. Therefore, we have 56 committees can be formed if there are 3 girls. Let us now summarize what we have discussed in this video. A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. The total number of combinations of n objects taken r at a time is given by the formula n factorial all over quantity n minus r factorial times r factorial. Let us now check your knowledge. Answer the following 3 problems, and do not forget to pause this video while doing this activity. How many possible combinations are there in the 642 Philippine Lotto? This one can be represented as combination of 42 taken 6 at a time. So we will have 42 factorial all over 42 minus 6 factorial times 6 factorial. 42 factorial all over 36 factorial times 6 factorial. Expanding our numerator, we will have 42 times 41 times 40 times 39 times 38 times 37 times 36 factorial all over 36 factorial times 6 factorial. Cancelling the common factor, which is 36 factorial, and simplifying the numerator and the denominator, that will be equal to 3,776,965,920 divided by 720, or simply 5,245,786. That means that we have 5,245,786 total combinations in the 6 over 42 Philippine Lotto. 7 points lie on a circle. How many inscribed quadrilaterals can be constructed having any 4 of these points are vertices? This problem can be represented by a combination of 7 taken 4 at a time, since a quadrilateral has 4 vertices, and there are 7 points that lies on the circle. 7C4 is equal to 7 factorial all over 7 minus 4 factorial times 4 factorial, or simply 7 factorial over 3 factorial times 4 factorial. Expanding the numerator, we will have 7 times 6 times 5 times 4 factorial all over 4 factorial times 3 factorial. Cancelling the common factor, which is 4 factorial, and simplifying the numerator and the denominator, we will arrive at 210 all over 6, or simply 35. A 5-person committee is to be formed from 6 men and 4 women. How many possible ways can we select the committee if at least 2 women are included? So we have 3 situations here. The first situation is that 2 women is included in the committee. The second situation is if there is 1 woman in the committee and Our third situation is if there are no women included in the committee. So we will have 6C3 times 4C2. This one represents that there are 2 women from a group of 4 and 3 boys or 3 men from a group of 6, since the total number of committee must be 5, plus 6C4 times 4C1. That is 1 woman from a group of 4 and 4 men from a group of 6 men. Because 4 plus 1 is equal to 5, which is the required number of persons in the committee. Plus 6C5 times 4C0. This one represents that there are no women included in the committee. So therefore, we have to pick 5 men from a group of 6 and 0 women or woman from a group of 4. Let us first solve for 6C3 times 4C2. 6C3 is equal to 6 factorial all over quantity 6 minus 3 factorial times 3 factorial, or simply 6 minus 6 factorial all over 3 factorial times 3 factorial. Expanding the numerator, we will have 6 times 5 times 4 times 3 factorial all over 3 factorial times 3 factorial. Cancelling the common factor, which is 3 factorial, and simplifying our fraction, we will arrive at 120 all over 6, or simply 20. Evaluate for C2. That is equal to 4 factorial all over 4 minus 2 factorial times 2 factorial, or 4 factorial all over 2 factorial times 2 factorial. Expanding the numerator, that is equal to 4 times 3 times 2 factorial all over 2 factorial times 2 factorial. We may now cancel the common factor, which is 2 factorial. That will be equal to 12 all over 2, or simply 6. Multiplying 20 by 6 to get the first result, that is equal to 20 times 6 equals 120. Let us now solve for the second group, the second situation. If there is 1 woman included in the committee, let us first solve for 6C4. We have 6 factorial all over quantity 6 minus 4 factorial times 4 factorial. That is equal to 6 factorial all over 4 factorial times 2 factorial. Expanding the numerator, we will have 6 times 5 times 4 factorial all over 4 factorial times 2 factorial. Cancelling the common factor, which is 4 factorial, we will have 30 over 2, or simply 15. Evaluating for C1, we will have 4 factorial all over 4 minus 1 factorial times 1 factorial, or simply 4 factorial over 3 factorial times 1 factorial, which is equal to 4 over 1, or simply 4. 15 times 4 is equal to 60. Let us now solve for our third situation, wherein no woman is included as a member of the committee. Let us first evaluate 6C5. That is 6 factorial all over quantity 6 minus 5 factorial times 5 factorial, or simply 6 factorial over 1 factorial times 5 factorial. 6 times 5 factorial all over 5 factorial times 1 factorial. Cancelling the common factor, which is 5 factorial, that is equal to 6 times 6 over 1, or simply 6. Evaluating for C0, or combination of 4 taken 0 at a time, we have 4 factorial all over 4 minus 0 factorial over 0 factorial, or simply 4 factorial over 4 factorial, which is equal to 1. Multiplying 6 by 1, that is equal to 6. To compute for the total number of possible ways, can we select if there are at least 2 women included in the committee? We will now add the results from the 3 situations. That is equal to 120 plus 60 plus 6, which is equal to 186. Therefore, we have 186 possible ways. Can we select the committee if there are at least two women included from a group of 6 men and 4 women. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Always have fun in learning math. Enjoy learning! Thank you and God bless.